Welcome back to the ICND1 series, and in this video we'll be looking at configuring VTP. So this video will continue on from the previous video. Now currently I've got set up two switches which have a connection to each other, and I've already got some VLANs set up on these two switches, so VLANs 10 and VLANs 20. These switches are currently in transparent mode, which means that when I configure these VLANs, I had to go into each switch and configure them individually. So I'm going to pause the video very quickly, and I'm going to bring up a console connection to switch 1. So now I'm on switch 1. Before we do any configuration, I just want to see some current information about VTP. So use the show Vtp status command. We can see the version of VTP we are running is version 2. There is a VTP version 3 as well, but currently we're only going to cover and run version 2. Number of VLANs supported locally is 1005. Number of existing VLANs is 7. As you can see, the configuration revision number is 0. The reason why is because even though we have configured VLANs, we have incremented the VLANs. So the current mode is transparent mode. So now what we're going to do now, so we've got switch 1 and switch 2. I'm going to configure switch 1 as server mode and switch 2 in client mode. Okay, so now to do that, we're going to go to configuration tier terminal, VTP mode server. Show VTP status. We can see that the operator mode is server and the domain name is null, it's nothing. Now to configure the domain name, we have to go back to global configuration mode and use the VTP domain command. In this case, I'm going to set the domain name to Cisco. So it's changed from null to Cisco show VTP status. Okay. Now I'm going to create additional VLANs. In this case, VLAN 30 and VLAN 40, and show VTP status. We can see that the configuration revision number has been incremented from 0 to 2. The reason why is because I configured 2 VLANs. Now if I was going to go into VLAN 20 now, no VLAN 30, and change the name, so let's change the name to HR. Go into VLAN 40 and change the name to finance. Example, these are just example departments that we could have in our company. If I issue the show VTP status command again, we can see that the configuration revision number has been incremented to 4. So whenever we change, add or delete a VLAN, the configuration revision number is incremented by 1 each time we make a single change. Now where is this VLAN information configured? No, saved, sorry. Each of the Abdur-Raheen command. By default, when we're running VTP, so VTP server or client mode, VLAN information is saved in what's called the vlan.dat file. This is a file stored in Flash, and this is where our VLAN information is saved. When we're running VTP transparent mode, the VLAN information is saved in the startup config file. So when we're doing, if I wanted to delete the VLAN database on a switch, I would have to delete the vlan.dat file with this command. So delete flash vlan.dat. This would erase the VLAN database and get rid of all of our VLANs. If I was running VTP transparent mode and I wanted to get rid of the VLANs, all I would just do, I would just go into VLAN configuration mode and use the no VLAN command. So no VLAN 10 or no VLAN 20 or no VLAN 30. So we've got VTP configured. Now what I'm going to do, I'm going to go over to switch 2, enable it for VTP client mode. I'm not going to give it a domain name yet. I'm going to let it inherit the domain name for switch 1. Then I'm going to come back to switch 1 and then enable the port which connects switch 1 to switch 2. So now I'm back on switch 2. Show VTP status. As you can see, it's in transparent mode. It doesn't have a domain name. Number of existing VLANs is 7. The reason why is because remember I configured VLANs 10 and 20 before in VTP transparent mode. So now I'm going to go to global configuration mode, config terminal, and I'm going to use the command VTP mode client. Okay, now I'm going to move back to switch 1 and I'm going to enable the trunk port which connects switch 1 to switch 2. I'm back to switch 1, configuration terminal, interface FA0/2, no shutdown. Let's bring the link back up. Show VTP status. We can see Cisco server. Once the link comes back up and is working properly, it should now send over its VTP information to switch 2. Let's just let it start forwarding traffic. It takes a bit of time. STP spanning tree is covered in the ICND2 series. It takes a bit of time for spanning tree to go forwarding on this port. Okay, but we can see, if I were to show VLAN, we expect now to see VLANs 30 and 40 on switch 2, and we expect to see VLANs HR and finance on switch 3 as well. On switch 2, sorry. Show interfaces trunk. Okay, interfaces are now running. Show VLAN brief. Okay, now I'm going to move back over to switch 2, and we're going to see if it has learned of this information automatically via VTP. Now back to switch 2, we're going to issue the show VTP status command again. As we can see, it's inherited the domain name from switch 1, and number of existing VLANs is 9, and it's inherited the configuration revision number. So it should have now synchronized its VLAN database with that of switch 1. So show VLAN brief. We can see now it's learnt of VLAN 30 and 40, even though we didn't configure the VLANs on switch 2. It learnt it via VTP from switch 1. So now I'm going to move back to switch 1, and I'm going to configure switch 1 with a VTP password. I'm going to configure an additional VLAN, and then I'm going to see that without configuring a password, does switch 2 now synchronize its database with switch 1. So back to switch 1, configuration terminal, VTP password, set this password to Cisco, or lowercase. Okay, now I'm going to configure another VLAN called VLAN 60. Okay, name of manufacturing, and show VLAN brief. We see VLAN 60 now listed was a name of manufacturing, and show VTP status. The configuration revision number now is 5. Number of existing VLANs is 10. Now we're going to move back over to switch 2 and see if it has learnt of this VLAN now via VTP, and see if it's synchronized its database with switch 1. Okay, so show VTP status on switch 2. Okay, configuration revision number still 4. Number of VLANs is still 9. Show VLAN brief. As you can see, it has learnt of this information via VTP. The reason why switch 1's configured with a VTP password, switch 2 isn't. Because switch 2 isn't, it's not accepting VTP messages from switch 1 because they have different passwords. Switch 2 doesn't have a password as switch 1 does, and the password cannot be inherited. So like with the domain name, if a switch doesn't have a domain name or has a domain name of null, it will inherit the domain name of the first VTP message it receives. The password has to be configured on each device individually. So now if I configure a password, VTP password Cisco, and it's important that it's case sensitive. So the spaces we use, exactly how we type it on switch 1, that's how we have to type it on switch 2. And show VTP status. Let's see if it's synchronized. Still at 4, give it a while to synchronize. Show VLAN brief. The VTP information sent every 5 minutes by default, so we might be here a while. So what I'm going to do instead, I'm going to go back on switch 1 and configure another VLAN and see if it propagates the information to switch 2. So all I'm going to do now is move into global configuration mode, VLAN 70, exit, and show VTP status. Okay, configuration number 6, VLAN 7. Is there any other commands we can use? Show VTP. We can use passwords, the password which is configured, and show VTP counters. Okay, and for the show VLAN command, we can choose show VLAN brief. Okay, so we can see the VLANs which have been configured. Now we're going to move back to switch 2 and see if it's learned of the information via VTP. So I'm back to switch 2, show VTP status, and now we're synchronized the database with switch 1. The reason why I configured another VLAN on switch 1 was because by default messages only are sent every 5 minutes or when a change is made. So if we had waited for it to send it automatically, we would have been waiting here for 5 minutes. But by configuring another VLAN, it caused it to send VTP messages again And now because switch 2, show VTP password, has the same password as switch 1, it's now synchronized its database with that of switch 1. Show VLAN brief. We can see this. If I do a show interfaces trunk, we can see that all, no, sorry, it's the wrong command, show interfaces trunk, we can see that all VLANs are being allowed over this trunk link. And in reality, we should only allow VLAN 10 over this trunk link, because on switch 1 and switch 2, I've got 2 clients which connect to their switches, and those devices are in VLANs 10. So let's try to enable VTP pruning. VTP pruning enabled. Okay. So now it says we cannot modify VTP pruning unless we're in server mode. So I'm just going to quickly change this guy to server mode. And this is another reason why we don't use VTP, because any switch can become a VTP server, which means that we can easily just change the mode to server and configure VLANs that we shouldn't be configuring on that switch. VTP pruning has been enabled. If I go to show interfaces trunk, yes, we can see now that on this trunk link, okay, only VLAN 20 is allowed over this trunk link. If I do a show VLAN brief, okay, so I know what happened. So on the switch 1, I've put that device into VLAN 20, okay, and because VLAN 20 is the only VLAN on switch 1 which is active and which has a port assigned to it, that means that when we enable pruning on switch 2 is only allowing, so imagine this, we have switch 2, switch 1, switch 2 is only allowing traffic for VLAN 20 to flow in this direction, because VLAN 20 is the only VLAN on switch 1 which is active and has a port assigned to it. There would be no point in allowing VLANs 10, 20, 30, 40, 50, 60, 70 to be sent over this link, because there's no ports assigned to the VLANs, there's no devices in those VLANs. So it's only allowing VLANs 1 and 20 to be forwarded over this trunk link. These are the only VLANs that are not pruned. So whenever it receives any VLAN 20 traffic, it can forward that over this trunk link because there is a device in VLAN 20. Now we're gonna go over to switch 1 and we're gonna configure pruning on switch 1 as well. So now back to switch 1, and to configure pruning we go to global configuration mode, VTP pruning. So once we configure VTP pruning on the server, it's propagated to all of our other servers and all of our other clients. If I do show interface trunk, as you can see, only VLAN 1 and 10 are allowed over the trunk link. And again, the reason why, on switch 2 we have a port assigned to VLAN 10, and because that's the only VLAN which is active, it means that we're only allowing traffic of VLAN 10 to flow over this link. The reason why, because on this switch 2, we only, out of all the VLANs we have one device which connected to the switch. This device is in VLAN 10. So we're saying that we're allowed to fly traffic in VLAN 10 over this link so that we can reach the device in VLAN 10. As you can see, pruning is very, very useful. With pruning, it allows traffic, it only allows traffic that is needed over that trunk link. So in this case, we had device here in VLAN 20, we had device here in VLAN 10. So because there's a device here in VLAN 10, we're allowing VLAN 10 traffic to flow in this direction, and we're allowing VLAN 20 traffic to flow in this direction. So that now, devices in VLAN 20 can reach all of the devices in VLAN 20, and devices in VLAN 10 can reach all of the devices in VLAN 10. If this port was assigned to VLAN 10, that means the VLAN 10 traffic would be allowed in this direction and in this direction as well, because there is a device on either end of this trunk link in that VLAN. So pruning is very useful because it automatically allows only needed VLANs over the trunk in either direction, which makes it very, very useful. Now the last thing I'm going to do, I'm going to change this switch back to VTP transparent mode, and I'm going to configure a VLAN, so VLAN 100, and show VTP status. Here, as you can see, it still keeps its domain name, it's in transparent mode, configuration region numbers back to 0. Now because this is in VTP transparent mode, it's not going to propagate any VTP information over to switch 2. But just to be sure, let's check the VLAN is configured now on switch 2. So you show VTP status, VTP still enabled, show VLAN brief. As we can see, we configured the VLAN 100, but it's not showing up here. The reason why, because switch 1 is now configured in Vtp transfer mode, we can configure VLANs on that switch, but no VLAN information is propagated to another switch. Okay, so we've reached the end of this video, and we've seen how to configure VTP. We've seen how to configure the different VTP modes, VTP path to the VTP domain. We've seen how VTP can be used to propagate information, and we've seen how VTP pruning works. We see how VTP pruning prunes VLANs based on the, so in this case, they've altered two switches. Okay. The VLANs allowed in this direction depend on the VLANs which are active on this switch, and the VLANs allowed in this direction depend on the VLANs which are active on this switch. So switch 2 will know that VLAN 20 is the only VLAN active and a port assigned to it, so it's only going to allow VLAN 20 traffic in this direction. Switch 1 knows that VLAN 10 is the only VLAN active on this switch, so it's going to allow VLAN 10 traffic in this direction. I hope this has been informative for you, and I would like to thank you for viewing.